Hey guys, today we're going to be talking ratios, lesson 5.5. Learning targets today, you should be able to represent ratios using fractions, percentages, and the colon symbol. And you should be able to find equivalent ratios in order to find unknown quantities. So let's dive right in. Your warm-up for today, please press pause and take a moment to complete. All right, number one, let's take a look. Julia earned 52 of the 60 points on the most recent algebra test. What is her percentage correct? Rounded to the nearest tenth of a percent. Here we're talking about the percentage correct, so we're talking 52 out of 60. As a decimal, this comes out to be 0.86, repeating on the 6 there. So you'll see a 7 at the end of the decimal, simply because the calculator would round up to a 7 for us. So we would turn this into a percentage, 86.7%. We did come up with a 0.7 because it did ask for to the nearest tenth of a percent. In number 2, find Julia's test scores as a fraction in lowest terms. Her test score as a fraction is 52 out of 60. There's a factor of 4 in both the 52 and the 60. If we remove the factor of 4, we come up with 13/15. In both of these examples, we have actually just used a ratio. A ratio is something that describes how many times larger one number is compared to another. It compares quantities essentially with the same unit. In our warm-up, we were comparing points in both the numerator and the denominator. It's often described with words in order to have an idea of what the numbers stand for. The ratio comparing A to B can be written really in 4 different ways, where order does matter. A to B, the colon is read as a 2, A to B. We can compare it as a fraction, A over B, or A to B. We can take that fraction and write it as a decimal, and then we can take it also and write it as a percent. Ratios are usually simplified in lowest terms. We wouldn't use decimals or fractions in a ratio if possible, as far as each individual part. Ratios are sometimes represented as a decimal, but not a decimal within as one of the 2 parts. Taking a look, we're just going to dive right in for an example. There's a similar example to this on page 275 of your textbook. If David's foot is exactly 1 foot long, Julien's is only 10 inches long, write a ratio comparing Julien's foot size to David's. You'll see some suggestions. You should try those before revealing the answer. Press pause if necessary. Determine the order of the ratio. This is always important here. We are comparing Julien to David according to the final sentence. Ratio comparing Julien to David. So Julien does have to be the numerator. Substitute quantities for Julien and David. Julien's foot is 10 inches. David's foot is 1 foot. We do want to make sure that we have the same unit. That's what a ratio is. It compares the same unit. So let's go ahead and convert that 1 foot to 12 inches. That's a nice, easy conversion. Simplify in lowest terms, we would compare this ratio as 5 to 6. Of course, inches in both the numerator and the denominator would simplify out. Another example including discount and tax rates. There is an example very similar to this, also on page 275 of your textbook. Number 2, if you want to see another one kind of like this. A shirt normally selling for $30 is on sale for $25. The tax on the sale price is $1.93, so the total cost with tax is $26.93. So if we take a look, what is the discount rate? A discount rate is the ratio discount to the regular price. It's usually given as a percentage. So in this case, we also will want to find the tax rate. Tax rate is the ratio tax to the price, usually again given as a percent. So if we go back to part A and we want to find the discount rate, determine the order of the ratio. It does say the discount to the regular price. In this, we know what the discounted price is, $25, but we would actually need to make sure that we use the discount compared to the regular price. If we substitute in our quantities, that means we're substituting in then $5 to $30. Write it as a decimal. 0.16, the 6 is repeating. Again, we see the 7 appearing at the end simply because our calculator has rounded to the nearest, which in this case is rounding up to a 7. And as a percent here, we would say that this is about 16.7%. So the discount is about 16.7% on this particular shirt. The tax rate, again, is a percentage, usually given as a percentage. It compares a ratio, tax to price. So in this case, we're going to be comparing tax to price. So tax to price, tax would then be the numerator. Substitute our quantities, $1.93 compared with the price of the item, which is $25. First, we of course find the decimals, 0.0772, and as a percentage, 7.72%. Using ratios to find unknown quantities. There really are two ways to do this, depending on which way you prefer. I will show you both of the ways. You're welcome to use either in the classroom, as long as you are, of course, showing your work. So here I'm talking about a punch recipe. Looks like I may have forgotten an apostrophe there in your mother's plural. So let's go ahead and, there we go, put that in. So in your mother's punch recipe, she recommends 2 parts of cream soda to 3 parts pineapple orange juice. How much of each ingredient will you need if you wish to make 15 cups of punch? So again, what this means is 2 parts of cream soda to 3 parts of pineapple juice. So if I put in 2 cups of cream soda, I would put in 3 cups of pineapple orange juice. So the part is depending on how much, the size of the part depends on how much juice you'd like to make or how much punch you'd like to make. So if we'd like to do this by setting up an equation, which is one way that your book suggests, you'll see an example similar to this on page 276 of your textbook. We're going to choose a ratio. Cream soda to pineapple orange juice would be one option. We also could go pineapple orange juice to cream soda. The thing to remember is once you pick it, you got to stick with it. So in this case, when we go ahead and substitute in our quantities then, we would say 2 parts to 3 parts. Since we don't know what the part is, because that's what we're trying to find is how much is 2 parts. Once we know the size of the part, we would then be able to determine how much the 2 parts actually is. We're going to use the variable p to represent that part. So 2p over 3p, which would indicate then that we would add the parts, the 2p plus the 3p, to get our total desired punch, 15 cups. So if our 2p for the parts of cream soda and our 3p, the parts of pineapple juice, equals 15 cups, we can solve this particular equation. 5p equals 15 then. Dividing by 5 tells us that p equals 3. Now, we've actually found out what each part represents. Each part represents 3 cups. So if we multiply 2 times 3 cups, we'd get 6 cups of cream soda. And if we multiply 3 times 3, we get 9 cups of pineapple juice. This is one way to do it. Another way to do it is to use something called ratio notation, including a total. A ratio can be used to describe more than just 2 items. So we could do a ratio notation indicating the parts of soda compared with the parts of pineapple juice compared with the total parts. So if we have 2 parts of soda, 3 parts of pineapple juice, that would be 5 parts total. So our total here is indicated as a 5. We do know that we want our total to be 15 cups. In order to turn a 5 into a 15 cups, we had to multiply by 3 cups. 5 times 3 cups would give us 15 cups. So we could multiply 2 times 3 cups and 3 times 3 cups to find out that we'd have 6 cups of soda and 9 cups of pineapple orange juice. This is another way of doing it. Some people like it. It is very similar to finding equal fractions. Sometimes we deal with changing ratios. So let's take a look here. Jeremy is 10 years old and Jeremiah is 12 years old. And how many years will the ratio of Jeremy's age to Jeremiah's age be 1/2? Obviously, if we were to compare Jeremy's age to Jeremiah's age at this point, we would not get a ratio of 1/2. We'd actually get a ratio of 5/6. So what we're taking a look at here is setting up an equation. If we let x be the number of years from now, we know we're going to be comparing Jeremy to Jeremiah and that we would like it to be equal to 0.5 or 1/2. So x years from now, Jeremy's age will be 10 plus x. And x years from now, Jeremiah's age will be 12 plus x. So how many years from now? We're letting x be the number of years from now. X years from now, Jeremy is 10 plus x, and Jeremiah is 12 plus x, so their ratio looks like this. If we want to solve this ratio to find out what x is, we're going to multiply both sides by the denominator here, 12 plus x. So take a moment to go ahead and do that. Press pause if necessary. We should result in 10 plus x. The 12 plus x will simplify out with the denominator on the left side, is equal to 0.5 times 12 plus x. Go ahead and use your distributive property. We find that 10 plus x equals 6 plus 0.5x. At this point, we have variable on both sides, so let's add negative 0.5x to both sides. 10 plus 0.5x equals 6. We're going to eliminate our constant, add a negative 10 on both sides. So 0.5x equals negative 4. And of course, our final step here is to get rid of the coefficient by dividing both sides by 0.5. And we just found out that x equals negative 8. So if x represents a number of years from now, negative 8 years from now, what does that really mean? That means 8 years ago. So we're actually subtracting 8. We're going back to 8 years ago. Jeremy would be 2, and Jeremiah would have been 4. So the ratio 2 to 4 is equal to 0.5. We'll see a few more examples in class tomorrow, and then you'll have a chance to practice and ask questions.